All right. Thank you all for coming today. We will be talking about the journey that Symantec went through on the big data platform, specifically building a large data lake and to support hundreds of new application developers who are new to Hadoop and trying to onboard them into the platform. So it'll be my colleague Narendra and me talking today. So here's the agenda for the day. We'll go through a very brief introduction, and then about the company and the team, and then we'll get into some of the big data platform challenges and the solution that we kind of came up with, which is the self-service analytics platform that we built, and then we'll show you how we are starting to leverage Cloudbreak more and more as we go on, and then finally also talk about how we ingest data into these self-service analytics platforms. So simple introduction. So Symantec, probably most of you know, it's the world's largest security software company at this point. There are thousands of enterprises and millions of endpoint devices that are being secured with Symantec software today. Right, and we are part of the cloud platform engineering team within Symantec, and the charter for us is to build a cloud infrastructure and data platform for the next generation applications. All right, that's dependent on the large data set that we are getting. So we are currently building a big data platform both on Hadoop and OpenStack, and we are actually building a lot of gaps and bridging a lot of gaps as we find in these. So what is the current challenge that we have, right? So Symantec, like I was saying, there are like hundreds of millions of users that are sending billions of events every day. We are, right now, in our current production system, we are collecting about close to 100 billion events every day. And that's a big change, right? So our current system was built on a lot of Oracle and Greenplum, and those systems are not able to scale up to 100 terabytes a day. So now we are actually storing all of this data in Hadoop. And we are also having hundreds of application developers who are coming on board to write applications to get more information out of this data. So right now, our cluster is about 12 petabytes. It's actually growing exponentially. We are hoping to hit close to 100 petabytes by the end of this year, right? So, and as we grow exponentially, and these developers are coming on board, there's also a challenge where there is lots and lots of new softwares and new upgrades of the softwares that are coming up. So we are part of the platform team, right? So, but the application teams, they always want new features. When Kafka 0.9 comes out, they want Kafka 0.9 right away. When Storm 1.0 comes out, they want it right away on the platform. So imagine the amount of complexity that we need to manage in terms of the different versions of different softwares on the platform. Right, so what happens? Soon frustration prevails because there is always requests from the product teams and the application developers that they want the latest Storm, latest Kafka, latest Spark. But as a platform team, we have to provide stability. Like, we cannot provide a platform that keeps crashing every time, right? So how do we solve this? We started thinking about and started talking to a lot of platform teams, and a lot of the times the request is, when Storm 1.0 comes out today, mostly they really, really want to just play with it and see if it solves some of their business cases, right? So instead of them coming and requesting us to upgrade the Storm, what if we give them their own cluster? They just go and play with it and get a subset of data. They develop whatever the application that they want with it. And then once they know that this is stable, this is good, this is what we want, then we can schedule a change to upgrade the platform on our end, right? So that's kind of the idea that we went into. But for them to build their own clusters, it's not easy for them, right? So we cannot just tell them, go build your own cluster, test all of this out, and then come back and let us know, right? And then we'll be happy to upgrade the platform to whatever the version you want. Because building cluster is not easy. There are too many services that you need to install, too many configurations, and whatnot. So what we decided was, let's abstract all of that out. Let's make sure that we give them one-click button, where they go in and say, I need a 10-node Storm cluster, right? They just go in and say that and click a button, they get a 10-node Storm cluster, right? So that's kind of the journey that we started along. So along with that, so we use Ambari extensively for a lot of this automation. So along with all the HDP softwares that Ambari supports, we also have a lot of other softwares that we wrote ourselves, and then also the other open source softwares that are used within the platform. For example, Cassandra is heavily used, Elasticsearch is heavily used, but Ambari does not support it. But what Ambari provides is an extension, like a Ambari custom stack that you can actually extend for any other services that you need. So we actually went in and wrote a lot of Ambari custom stack for a lot of these other open source products that are out there that is not supported by Ambari by default. All right, so now that brings us to our actual solution, self-service analytics platform that we built within Cloud Platform Engineering in Symantec, right? So what is SSA? It's basically a REST service that allows to create and manage your custom clusters. Right now, we have a predefined set of Ambari blueprints, which in a way is where the blueprints is one where you actually define the different services that you need within a cluster and everything. And the service basically goes in and spins up the VMs on our private OpenStack cloud. So our cloud, private cloud is built on OpenStack. And it also installs all the HDP stack and also the other custom services if needed. And then it also comes with a dashboard monitor to manage your clusters. So shortly, this is our current environment. We run on OpenStack ISAs. Our OpenStack does not come with heat templates. For whatever the reason, our cloud team decided they're not going to use heat templates. So we have to live with the OpenStack native APIs. And we are running HTTP 2.3.2 and Ambari 2.1.2. And we are actually on our way to move some of the workloads to public cloud as well, like AWS at this point. So this is a very quick high-level architecture of SSA, right? So basically, as a user, they basically come in and send their username and password to Keystone, which is the authentication service for OpenStack, and then they get an auth token back. And right after that, they basically send the auth token to SSA service, and then they just, while they call it, they just say what are the what is the different blueprint that they need for building this cluster, and then that's it. And then from that point on, SSA service basically takes that auth token and communicates with multiple different OpenStack services, like Nova for spinning up compute instances, Newton for setting up the IP addresses, floating IPs, and designate for DNS, and everything. And then it also installs the Ambari server and Ambari agents on all the nodes that it just spin up, and then it just submits a blueprint, whatever the blueprint the user wanted. So these are the different services that we have currently in SSA, right? So there is a list of templates that are available, so users can go in and find what are the different templates, which is basically a Ambari blueprint. They can get the details about all the templates. They can build a new cluster, get a status of a cluster, and get a list of clusters. So let's go through a very quick demo. This is a demo that we recorded last night. So we'll just go through very quickly. Oops. About what SSA actually does. So before I begin, the UI that you see, so like I said, it's all REST-based call, but the UI that we built, it's based on Rundeck. Rundeck is just a management tool which can be used to call any REST endpoints, or you can also do any SSH commands or whatnot. So we basically decided to use Rundeck to call these REST APIs so that the users have some sort of UI to go through this. So let me play this. So the first thing the user would do is they would basically go in and generate an auth token from Keystone. So they have their own OpenStack tenant, they have their own OpenStack domain, and each of these project and domain, tenant and domain will have their own quota, so users does not have unlimited resources, right? So each of the project teams will have their specific quota assigned. So if they have 10 developers, they can ask for 100 VMs, and that's all they would have, right? And then after they get the token, they go to the template list, and that would basically go in and make a call that would basically give back all the templates that we have currently, right? And they can choose whatever the template that they need. Like for this demo, we're going to choose a 5-node streaming template, and those are the different services that will be installed, and it also has the cardinality of what each of those services are in the cluster. Right, and then once that's done, they can go, once they know what the template they need, they go to the build cluster, and each cluster has a unique name in our platform. So they give a name, and they choose the template that they need, and that's it. They click run job now, and that's about it. So basically, this should return, it will also return the list of URLs that they can call back to get the status on this cluster, but basically the request to build a cluster has been submitted. Right, so now after this, you can actually go back and run another job to get the cluster information. This is basically the status for the cluster. You give your cluster name, and you get the status for your cluster. Right. So you can see there's multiple stages it goes through. Right now it says it's building VMs in OpenStack. So you will see this whole demo is about 10 minutes, so I'm not going to wait for 10 minutes. So I'm going to keep forwarding a bit so that you would see what happens. So now this is another status where it says it's assigning floating IPs right now. So as the user keeps checking the status, and within a few minutes, you would see that the cluster is actually built, and it would actually return. So again, this is now that all the servers are built, they have their IP addresses and their DNS records and everything is done. So it returns all of that. So the user can actually, if they want to, it's their own, it's all built under their own account in OpenStack under their own tenant. So they all have root access to these servers, right? So it's under their own account. So if they want to, they can actually SSH into the box and do whatever they want at this point. So we give all those details back. All right, now it's actually installing the Ambari server and the Ambari agents on the VMs that it just created. And then now it's actually building the cluster, which basically means it basically just submitted the blueprint to Ambari, right? So, and then eventually, you'll see, I might have fast forwarded a little bit more than what I wanted. So here, you can see the cluster is active, finally. And then now you can get the metadata, and this should actually return you the Ambari URL for the cluster. And that's it. Once they get the Ambari URL, it's totally up to the users. Now they have admin access to the Ambari, and they can go in and restart the services how many times they want, manage the cluster through Ambari. And so yeah, that's the Ambari URL, and then you would just basically see now that you can actually log in to that Ambari, the cluster that we just built. And it should give you a status. So you can see Ambari is actually reporting that it's actually building and installing all these services at this point. So that's it. So in a nutshell, you have a cluster built for yourself. It's your own custom cluster in less than 10 minutes, basically, right? So, and we are actually making more changes to it in terms of making it more dynamic on how people want to define their own services and things. So right now, like I said, it's all predefined Ambari blueprints that we have done based on the needs that we know within the company, right? But we are making more changes to it. So what are the pros and cons of this, right? So it makes spinning up of clusters a breeze. And we have a centralized dashboard to manage all of these clusters. And it is customizable to our private cloud that we have. One of the biggest cons for this, for us, is this is very tightly coupled to our private cloud. And just last month, a decision was made at the executive level saying we are going to go public, right? Because there is not enough space in our data center. Let's explore public cloud, right? So what does that mean to us? the first question that came up was, okay, so you have this code that can go into OpenStack Cloud and spin up the VM. Can you just take that code and point it to AWS and do the same thing? Unfortunately, we couldn't do that. So we started exploring a few other things, and we actually looked into Cloudbreak a few months ago when we started our OpenStack journey. And we kind of decided that we would do it on our own because there were some gaps with Cloudbreak on OpenStack. But now we are actually starting to fill those gaps along with the Cloudbreak team. So what is Cloudbreak? It's basically a tool that simplifies spinning up clusters on any public cloud, also OpenStack private cloud. And it pretty much uses the same thing that we did. It uses Apache Ambari. Cloudbreak also uses Docker to containerize some of the services. Right. Like I was saying, these were the gaps that we had when we first started our journey, when we looked at Cloudbreak. It did not support Keystone v3, right? So, and then it also did not support native OpenStack APIs. We had to have heat templates to use Cloudbreak. The biggest gap for us now is, so we have this SSA that's being used within the company, but that's a different system. And then if we use Cloudbreak for AWS and other public cloud, then we'll have two different systems that we need to maintain. So we started looking into it, and we decided to basically converge our code base with Cloudbreak. And we are actually in the process of doing it. We already contributed back to Cloudbreak for the Keystone v3 support. The native OpenStack API support is also going on without the heat template, and it'll be pretty much done pretty soon and contributed back. So the Keystone v3 support is already there. It's released on the latest version of Cloudbreak. If you go to the hosted version of Cloudbreak or download the Cloudbreak yourself and check it out, you can see there is a v3 Keystone in there that you can see. These are the screenshots from the cloud version of Cloudbreak, one in the cloud at this point. And you can also see it supports all the different parameters that are required by OpenStack Keystone version 3 to do this. All right, so in a nutshell, that's kind of how we did our self-service analytics platform. And then now I'll hand it on to Narendra to talk about data ingestion. Please.
So most of our product teams were able to spin up their clusters using SSA, and then the immediate question that used to follow up is, how do I get my data into the cluster? Because an empty cluster is like, is pretty much useless without any data in it. So as a platform team, we had to address that. The solution to that, what we provided was a data ingestion service. It's built on Trident, and we are trying to be like as close as exactly once. The main thing was to have low latency and then support different spouts, different sources and sinks. Inside Symantec, most of our previous products have been used to expose their data on RabbitMQ brokers or Kafka brokers. So we had to build a service that ideally used to consume from one of them and then push it into the new cluster which you build. Ideally, in most cases, our big data cluster used to have Kafka. So we are just assuming that the destination can be Kafka, but the source can always vary. We're also trying to increase this because we want to consume the data even from SQL and push it into Kafka, and they're coming up with different requirements, and as a platform team, we are trying to address that. So this is a quick architecture diagram around that. So we support different source points, Kafka, RabbitMQ, HDFS, and there is a spout which reads it, and then a bolt. It's as simple as you just have to configure a property file and say storm deploy on the SSA, and then on the cluster built via SSA, and then you should be able to consume all the data. We are planning to extend it using a sampler where you can throttle and say, I don't want all the data, I only want limited data, because if you build a dev cluster, you probably don't want all the production cluster data or something flowing inside that. So what I'll now show is a quick demo of it, and then that will explain most of the parts. So I'm going to just forward it just in case, because it's a long demo because I did the complete setup. So this is the RabbitMQ source point I have, and I'm trying to consume from the queue demo 1, which has 1,000 messages. And then I have a Storm UI on my local cluster, which was built using SSA. And it just shows that it's up and running. So what I will do now is go ahead and download the couple of property files and jars that I needed. If you can see here, what I did is I created a folder and then listed the two things that were there. We have hosted that our internal repository, so any product team can just download those. And there's one jar and one template file. All they have to do is update the template file with whatever, because RabbitMQ will have some properties like name, username, password. So they have to just update that as per the requirement. So the first thing what they are doing is saying that we have to run it on a remote cluster if Storm runs on both local cluster and remote cluster. And then I'm trying to say we have to only consume from one portion of RabbitMQ, one shard of RabbitMQ. Then we are updating the name. Then we'll update the destination Kafka URL. At this point, we have only one, so I'll just keep it to 1992, and then an output topic to where it has to be written. And once you make all those changes, you should be able to submit it using the standard Storm methods. Yeah, it's submitted. Now what should happen is simultaneously the UI should start showing that we are able to consume the messages, right? I'm consuming in batches of 100. You can see that on the UI, and the graphs reflect the same. What we can next go and check is on the Storm side whether the topology is deployed and it's doing some job. You can actually see it's consuming, and some messages have got agged, which confirms that, okay, it's going through. And let's wait. Okay, so what I'll do right now is on the Kafka side, I'll run a console consumer just to check if all my messages have received or not. I'm just picking up the destination Kafka topic name. Yeah, that's it. So we got all our 1,000 messages that were pumped. So we are running this in our production, and I'm like more than 4 or 5 product teams are running this to do sometimes for replication. If they build some, any developer builds up a dev cluster, he only wants 10% of the data. He uses it. And what we have also done is like precisely we have opened put it on GitHub and given 2 templates. One is the plain transfer where they'll transfer from the source to destination. The other one where they can go and write some custom functions and say, I only want this much percentage of data and stuff. And yeah, that's pretty much the data ingestion service.
All right. So again, we as a platform team, this was a journey for us. We have been, our platform team was formed about 1.5 years ago, and the first 6 months was pretty rocky, having a lot of these conversations with the product teams about the stuff that they need and about the stuff that platform team would provide and things like that. So this is a journey that we've been going through for the last 6 months. And our goal is to bring all of our platform needs under Cloudbreak, especially now that we are embarking into both private and public clouds. So we will be contributing all of our code with OpenStack native APIs that we have back to Cloudbreak and enable Cloudbreak to support our version of OpenStack at this point. And we are also actually looking into providing support within Cloudbreak for bare metal provisioning using OpenStack Ironic, right? So all of our servers within our team or provisioned bare metal servers are provisioned using Ironic, which is an OpenStack service. And we are actually looking into see if we can leverage that also to see if we can spin up a bare metal servers using Cloudbreak. We are actually working towards building a single large yarn cluster for a variety of compute needs. And then we will be working very closely with the Cloudbreak team and the large open source community to to address a lot of these gaps as we go on. And a lot of the code that we have written so far is already out there in GitHub. So that's the main page for Symantec open source contribution. So you can always go to github.com/Symantec. You can find all the code that we just talked about here today. And that's it. Any questions? Sure.
Are you going to support the SSA after the code has been merged to Cloudbreak or not?
We will. So the question was, are we going to support the code after SSA code after merging into Cloudbreak? That is the plan. We will continue to, because this code is very critical to our platform. So we will definitely be supporting it. That's the plan. Sure.
The data that you're going to feed into AWS, have you started already, like, deploy the clusters using the Cloudbreak in AWS, then interconnect and feed the data? And the challenge is that feeding so much data into AWS, and are you going to keep them there? Are they original? Are you anonymizing the data before you send them to AWS?
Yeah.
How do you handle that, please?
Yes, so the question was, let me repeat the question for everybody else. So the question was, when we go to AWS, how are we going to manage all the data that we want to feed into AWS? So that's actually a work in progress right now. So we actually have a huge need in terms of amount of data that we want to push to AWS. So we are actually working very closely with the AWS team on that, on setting up the network pipeline between our data center and AWS. So we are actually using their direct connect. And in terms of whether are we going to keep all the data there, we are also looking into archiving some of the data as it gets old into probably Amazon Glacier or something, and we're not probably going to keep all the data in the EC2 HDFS cluster forever, right? And as far as how we are going to secure it, we are actually looking into multiple options for encryption. Right now, the HDFS encryption is probably going to be a little bit tricky for us, but we are also looking into multiple different options. Like maybe we can use the default AWS volume encryption that it provides, right? So that's kind of some of the work that's going on right now.
Kafka security also, Kafka ACLs. We're looking into Kafka security and encryptions. So probably we'll use that for data in motion. For the Kafka release is a newer version where you can encrypt all your data using SSL certificates and then use ACL. So we did a pilot with that as well. So it's still in progress.
Sure.
AWS implementation, have you been using, besides EC2 or security groups in the VPC, AWS for storage?
Yes.
Are you going to use EC2 only or EC2 S3?
Yeah, so right now our plan is to go completely on, so the question was, are we using S3 for backend or are we using EC2 completely? Right now our plan is to use EC2 completely. One of the biggest reasons for that is our data is primarily on Hive ORC format at this point, and the Hive ORC support for S3 is not there yet. I mean, there is a lot of work going on around it. But at this moment, it's not there. So we are actually going towards building our own HDFS cluster on EC2. We are not using S3 at this point. But eventually, we will move to S3 because of price point. S3 is much, much cheaper than running our own HDFS cluster in S2, but we will go there at some point. Sure.
For the clusters you're spinning up in OpenStack, how are you treating the networking for that? Are you giving them all floating IP addresses for every machine you're spinning up? Or are you sequestering those in the private network and developers can do that?
Yes, so it is actually sequestered into a private network. They also, all of those nodes also get assigned a floating IP, right? So you can actually access them from outside the network, outside the firewall boundary. But these all these clusters, all these nodes are within a sequestered boundary within their own OpenStack tenant, right? So each OpenStack tenant has their own private network, and these will all be part of that network. Sure.
Now, on AWS, you said you're not using the templating in your OpenStack yet, but in AWS, there are some advantages using templating. Are you just going to implement rather blueprints versus templating, or templating versus blueprints in Ambari?
I think it will be both. So we'll definitely probably be using a lot of the AWS template features that they provide, like cloud formation templates, for spinning up the VMs. But as far as setting up the Hadoop cluster itself, will still rely on Embody blueprints. I think Cloudbreak still relies on Embody blueprint anyways for setting up the clusters.
Ambari on the AWS is dependent on the AWS DNS integration. So are you planning to retain that, and forwarding on to handle all these integrations, or are you planning to kind of integrate your own DNS with IP addressing schemas, or you don't know yet? You didn't test that.
No, we haven't gotten that far yet, but we at this point we will have our own DNS, right? So that's so that's the idea that we are looking at. But I don't think we have actually. So a lot of the POCs that we did, we used whatever AWS provided. But the eventual goal when we go to production will be there will be some changes there for sure. Sure.
So if I understood, you have future plans regarding Cloudbreak on bare metal. What's your timeline or expectations?
So our immediate needs right now is to get OpenStack VMs and AWS done in Cloudbreak for our production cluster. So I would say at least another 3 to 6 months before we can get a good pace on the bare metal. So 3 to 6 months.
So you are using Ambari blueprints to install the root cluster itself, but what you are using is in your SSA to install Ambari. Are you using something like configuration management as well?
No, so we are not. So we use Puppet primarily on. So we actually, first version we used Puppet pretty extensively, and then we actually ran into a lot of challenges with maintaining Puppet, right? So eventually we actually got rid of that, and then we actually moved to shell script. So it's actually pretty easy because at the end of the day, it's just three commands that you need to run to install an Embody server and an Embody agent, and we decided that's probably easier to do that. The only reason why you would want to use Puppet or some other configuration management tool is if you want to keep that server, that cluster from not getting changed from any of its configuration, right? But now that these are primarily, at least for the first version, going to be for short-term development purposes, we just didn't think we just thought there was too much complexity to add to this, so we just removed that. So yeah, we did try with Puppet for a bit, and all of our production clusters we are using Puppet, but yeah.
So how many of these smaller clusters are you running at any one time, and how long do they tend to live for?
So right now, currently, we have at least about 50 or 60 clusters, and most of these clusters are, some of these clusters are long-lived, right? For example, a group might spin up their own dev cluster, right? And that's long-lived. But a lot of the clusters that the developers build for themselves, it's probably like a month, 2 months. They just do it for a project, spin it up, test with the new version that came out, and then they're done. They move on. And one of the biggest thing for us is to enforce quota there, right? So because a group will have, like within an OpenStack, a tenant will have capacity for 100 VMs, and then once 10 developers spin up 10 clusters, it's gone, right? So now they need to make sure they manage the resources between themselves. So.
Does the Cloudbreak offer you functionalities where you can set the dev clusters only operational in the business hours, or those functionalities are not yet integrated in that way?
Yeah, I don't think it's there at this point.
No, I don't think.
Yeah.
Do you manage that as well?
So right now, since this is all, so far what we've done is all within our own private cloud, we are not really managing that very well, but when we go to AWS, we definitely have to do that, right? So we will be looking into some of those things, yes. Sure.
So when you tear down the clusters, are you zeroing out the disks as well, or
We are.
tool that you can sort of take them offline long enough so that can get done, but not impacting the next thing?
No, yeah, we are actually tearing down everything. When we delete a cluster, it actually goes in and just deletes all the resources for a given VM, and then just tears down the VM as well. It just deletes everything, including the network that it used, the DNS entries, everything just gets wiped off. Sure.
Do you ingest historical data?
Historical data?
Yeah,
Yes, so we do. There is a different service that we have. It's primarily file-based at this point. If somebody needs, they can still use that. But that service is primarily being used in our production clusters at this point, rather than in some of these clusters. But yeah, we do have a service that if people want to use, they can. There is a file-based ingestion service along with the
Data
Kafka
ingestion.
service that Narendra talked about. But this is the biggest need for us because a lot of our data are coming in as events from a lot of these Symantec agents that are running in endpoints. So we need an ability to divert at least few percentage of that data into this dev cluster so people can develop. Sure.
How do you deal with updates for
update them at all? Do you update them sometimes?
No, so not for these clusters. So the SLAs for these clusters are primarily you spin it up and do your research, do your development. Once you're good, you use it. If you need a new version, spin up a new cluster. Tear this down, spin up a new cluster, right? But there, like I said, there are some development clusters and QA clusters that is shared by multiple teams at this point, and we do manage that, right? So, but that's where the problem comes, where people need new softwares on these shared clusters, and it becomes a bigger problem. So whenever that need comes where somebody needs a newer software than that's being in the shared cluster, then we ask them to just use this, test it out, and then if everything is looking good, then we'll schedule a change for that, right? So. Any other questions?
Did you evaluate the cost between AWS already running the same clusters in AWS versus running them on-prem in terms of if you run them 100% of the time or 50% of the time?
So yeah, it's a difference between capex and opex, right? So it depends on how effectively we'll use AWS, right? So there is really no good way to figure out an opex for our private cluster that we have, because it's some money that we already spent. The servers are there in our data center, right? So it'll be like comparing apples and oranges if you really do that. But yeah, I mean, we are doing a lot of performance benchmarks for sure, but cost differences, it's hard to compare.
Because OpenStack doesn't have any functionality for pricing.
Not really, yes.
For the resource pricing per department or something where else in AWS you can already introduce that.
That's right. Yeah. It will actually make our life much more easier as a platform team with AWS, because it's easy for us to let the product teams know how much resources, what's the cost of the resources they're consuming pretty easily, right? So, yes. Cool. Thank you very much.
Thank you.